this is going to be 7.3. And you can't miss it. We are going to call it integration by trigonometric substitution. We're going to call it trig substitution. Okay, trigonometric substitution. That's it. Trigonometric substitution method, if you like. Okay, so what's the idea? We have some radical function, okay, in the following format. So that's it, the following. Identity. There are 3 types. I'm going to list them and show you how I'm going to use it. The following trigonometric, okay, trigonometric identities, those famous one. They're going to be the one that usually perfect squares. So one of them is this one, cosine squared of theta is going to be 1 minus sine square of the theta. That's the first one. Okay, the second one is secant square of the theta is equal to the 1 plus tan square of the theta. That's the second one. And the third one is going to be tan square of the theta. We just remove this one to the other side. Secant square of the theta minus 1. You see, they are all perfect squares. It helps us to remove the radicals. Okay, so the following trigonometric identities and trig substitution and trigonometric substitutions. Okay, can be used to take care of the following. To integrate, okay, to integrate the following, okay, the following radical expressions, okay, I'm sorry, I missed that. The trigonometric substitution can be used, I'm going to show you. Okay, can be used to integrate the following radical expressions. Now, how we're going to do it, you see, the following are going to be, corresponds to the first one, we are going to have a square minus x square. If this is given to you, the substitution that you're going to pick, you are going to change it into this format. So you need a cosine square to remove it. So the substitution for this one is going to be x equal to the a sine of the theta. When you substitute, you end up with the 1 minus sine square, radical cosine, and you take the square root and you're done. So that's the first one. For the second format, if you have a squared plus x squared, you're going to use this one. So in this case, you are going to pick the x to be a tan of the theta, because when you substitute, you end up with the secant squared, you take the square root and you're done. Okay, and if you have that last one, and if you have what? If you have x squared minus a squared. So you're going to change it to this format. So you're going to the x, take the x to be equal to the what? X equal to the a secant of the theta. If you get a secant of the theta, so that make it to the secant square minus 1. Okay, secant square minus 1. And then you substitute that, give you tan square, and then you're done. Okay. But when you do this integration, you have to simplify it, simplify the result. So as soon as we get this one, we are going to find the sine of the theta, which is going to be x over a. At the end, you have to go back and substitute. You see, you change it to the theta. Then at the end, you have to get back and change it to the x. In order to change it to the x, we are going to use this right triangle version. You see, it's going to be right triangle. This is going to be your theta. You know that the sign is going to be the opposite. This is x over the hypotenuse, if you like. So it's going to be x over a. So this is going to be your a. So according to the trig trigonometric Pythagorean identity, so this is going to be a squared minus x squared. Okay, so if everything is all right, you will see this one right away. Okay, for this one, you have the tan of the theta is going to be equal to the x over a. So your triangle would be of this format. This is going to be your theta. The tangent is the opposite side over the adjacent. So according to the Pythagorean identity, this must be a squared plus x squared. You see, this quantity must be one of the sides of your right triangle. And over here, you are going to have a secant of the theta. Secant of the theta would be x over a. Secant is like 1 over cosine. So this is going to be your theta. So this is a secant, you know, that the cosine would be a over x, and the cosine is the opposite side over the adjacent, which is the opposite side over the adjacent. So this must be what? This would be x squared minus a squared, the square root. You see, if you do it all right, you must have it, get it on those right triangle. I'm going to do it, you see it. So I get my substitution and I bring this at the end. Easily I can go back and substitute the result, okay? So let's see how we're going to do it. Step by step. It's kind of 3 problems and we give all those 3 on your next step. Okay, next quiz. So example. We want to evaluate each integral. Okay, there you are. Evaluate each integral. Type 1 is this one. They're all the same. It's a squared. You have to give a number. 4 minus x squared, 9 minus x squared, 25 minus x squared. They're all going to be all the same. Okay, so the first one is very standard, the most popular one. Okay, so let's have something like 4 minus x squared dx. So you realize that you must use the substitution that we talk about it. So the substitution is going to be type 1. So your solution is going to be, you see, your a squared, if you like, is 4. So a would be 2. Okay, so a is equal to 2. So you're going to pick the x to be equal to the what? Is equal to the true sine of the theta. Okay, that's your x. So what you're going to do is, and this is going to be your x. Make sure you pick you are going to pick the sine of the theta. The sine of the theta would be x over 2. Get your right triangle. This is going to be your theta. And your sine is going to be what? Is going to be x over 2. So this would be 4 minus x squared. Do this one, we can do it right at the end or just do it now. Just make sure that as soon as you get the x, also make sure you get the dx. If things getting complicated, probably you miss the dx. This is the only place that you may miss it. Okay, that's going to be your first job. Now simplify this one as much as you can, then go back and substitute. Or you can substitute right away, it doesn't matter really which one, okay, the way you are going to do it. So if you want to stay in, it's going to be 4 minus x squared dx, substitute. It's going to be the square root of, this is going to be 4 minus x squared, would be 4 sine squared of the theta, times the dx, which is going to be times it by 2 cosine of the theta d theta. That's the one. So you factor out the 4 here, so that give you, Okay, if you factor out the 4, so that give you 2x squared. Okay, so that's going to be the 1. So if you factor out the 4, so it's going to be 4 times 1 minus sine square of the theta, and that's a 2 cosine of the theta d theta. Then that would be cosine squared. You better simplify it inside, okay, before getting to the radical. So that would be 4 cosine square of the theta, and this is going to be 2 cosine of the theta d theta. When we talk about the, okay, in this case, because we talk about the inverse function, so your theta is between negative pi half and the pi half. Okay, this means the cosine is always positive. So the cosine is positive for all of these. So when you take the square root, you don't need to have a positive or negative. So that's 1 point again. So that's going to be 2 cosine of the theta times 2 cosine of the theta, which is going to be 2 cosine squared. This integral would end up with the cosine square all the time. The only time this is 4, this is 2. If it's going to be 9, this is going to be 3. 25, 5. Everything else is going to be the same thing. Okay, so sorry, that's a 2 times 2, 4. 2 times 2, 4. So you have to find this integral for all of them. Integral of a cosine square. It's the only thing that you're going to use. Okay, so it's going to be 4 times integral of cosine square of the d theta. You know that. It's a cosine square, you have to use the double angle formula to take care of it. So it's going to be 4 times integral of 1 plus 1 minus, and just plus, cosine of the double angle 2 theta divided by 2 d theta. You can pull out the 2. Okay, so the 4 and the 2 simplify. So it's going to be 2 times integral of 1 plus cosine of the 2 theta d theta. Now you integrate it. So that's going to be 2 times the integral of 1 is theta. Integral of a cosine is going to be sine. So it's going to be sine of the 2 theta divided by 2, but plus the constant c. You have to simplify this one. Sine of the theta, sine of 2 theta is always 2 sine of the theta cosine of the theta from the trig identities over 2 plus c. These 2 and 2 will cancel out. So the final answer would be 2 theta plus 2 sine of the theta cosine of the theta plus c. So this is always the final answer. Now you have to substitute. We don't accept any inverse function, remember. For this, you have to substitute to get these numbers. So for substitution, it's going to be, you go back to the whatever you have. You say, remember your substitution was sine of theta equal to the, okay, that was the sine of theta equal to the x half. I bring it here again. So that's the theta. The sine is going to be, this is it, the opposite adjacent. So this is 4 minus x squared. So I need theta. To get the theta, I use the inverse function. So the theta is going to be the sine inverse of x half. This is your substitute for the theta. Sine cosine. Just substitute this, okay? So what's going to be the final answer? The final answer is you have 4 minus x squared dx is equal to 2 theta, means 2 sine inverse of x half, plus 4 sine times cosine. The sine is x half. Cosine, you get it from this right triangle. The cosine is the opposite side over the hypotenuse. So it's going to be the square root of 4 minus x squared divided by 2, plus the constant c. One of these two would cancel out. So finally, 4 minus x squared dx is equal to is always equal to the 2 sine inverse of x half. Okay, and over here is going to be plus x square root of 4 minus x squared over 2 plus the constant c. That give you the final answer. And this is the way you write it down on the test first. Okay, so it is not going to be a difficult case. Always you end up with a cosine squared. All of the problem of this type, cosine squared. So you have to use the double angle formula to take care of it. It's very standard format with the substitution method. Okay, so this is going to be type 1. It's very standard, but sometimes when they want to simplify it a little bit for you, you may change the format of the problem, but basically this is going to be one of the main one that we use for this type of problems. Okay, so that's type 1, very standard, nothing to worry about. Be prepared for it. We give you one of them on your next test. So that is for the type 1. For the type 2, okay, so for the type 2, we are going to try this one. We want to check something a squared plus x squared. If you write it down just as the given one, it's a little bit difficult, but we try it. See if you have something like, let's say 9 plus x squared dx. This would always end up with a secant cubed. Then you have to take care of those secant cubed. So sometimes we divide it by x or multiply by something to make it easier. But if you want to have just the standard one, so the format for this one is going to be, you need 1 plus tan squared to take care of it. So this is it. You take the x to be equal to the 2 tan of theta. This must be your substitution. Okay, so that would tell you that the tan of theta would be x half for the end of the problem. And make sure to get the dx. The dx would be 2. The derivative of a tangent would be secant the square of the theta d theta. Okay. You can simplify it as much as you can, then go inside. So it's a 9 plus x squared. If you substitute, that give you 9 plus, I'm sorry, this must be 3. 3. Okay, and that's a 3, sorry. Because I want it to be 9. You see, that's a squared is 9, so a must be 3. Because otherwise you cannot factor it here. So x squared would be 9 tan squared of the theta. So that gives you 9 times 1 plus tan squared of the theta. 1 plus tan squared would be secant squared. So that gives you 9 secant squared of the theta. As we talk about it, the secant is positive. So the result would be 3 secant of the theta. Okay, so that would be this radical part. Then you go back and substitute. So originally you did have 9 plus x squared dx. You substitute, the radical is 3 secant all the time. It's going to be times by the dx, and the dx is 3 secant square of the theta d theta. As you can see, you end up with the secant cube. 3 times 3 would be 9. So it's going to be 9 integral of a secant cube of the theta d theta. Good luck. You know that you have to use integration by parts, to find it, and then substitute to get your result. Okay, so just check your lecture notes for the secant cube. You have to find it. We did it before. See, this is secant cubed. That's a secant cube, 1/2 of a secant tangent plus the 1/2 of the ln, then you just substitute to get this result, okay? If it's going on the test, you have to do it to get these numbers. That's why we give you something that enable you to simplify it a little bit. Otherwise, it takes time, it's unavoidable, this function. Okay, so if you like, if you want to continue to get these numbers, you have to substitute this one. So you just go with the secant cube of the data, d data, as we have it over there. I just have to check again. So it's a 1/2 of a secant tan. Is a 1/2 of the secant 10, and is a 1/2 of the ln of the absolute value of a secant 10 plus tangent plus the constant c. I think that's it. That's it. The one that we checked it. Yes. Okay. So then you have to substitute to get these numbers done. Okay. So you have the 9. So basically, integral of the radical 9 plus x squared dx is going to be 9 times this, so it's going to be 9/2 secant of the data tangent of the data plus 9/2 ln of the absolute value of a secant of the data plus 10 of the data plus c. Then you have to substitute here, so you have the tangent of the data. Tangent of the data is x third, so we get the right triangle. You see, this is going to be your data. The tangent is the opposite over the adjacent. So this is going to be that 9 plus x squared that you have. Just substitute here. So 9 plus x squared dx is equal to the 9/2 of the secant. Secant is like 1 over cosine. The cosine would be, 3 over, so do it the other way around. So it's going to be radical 9 plus x squared over 3. That's a secant times the tangent, which is x third. Then you repeat it here, 9/2 ln of the absolute value of a secant, which is 9 plus x squared over 3, plus the tangent, which is x third, plus c. A little bit simplification. 3 times 3 would be 9, and the 9 would cancel out. This is it. So the final answer, 9 plus x squared dx is going to be a square root of a 9 plus x squared half times x, of course, x, and plus 9/2 of the ln of the absolute value of a 9 plus x squared third plus x third plus the constancy. So that's as I told you, this integral is a little bit too much. Not bad, not difficult, but it takes times. We usually simplify it. What we do is when we want to give you on the test, we just put something. You see this, the one we divide it by x, or if we write it as a fraction so that we're able to simplify this secant cube, then you'll be fine. So okay, that's it. That's the standard one. But the way you are going to see it is a little bit simplification. Let me just give you another one to see what I mean. You see, they give you in this form. It's going to be something like a power on the top, so that will take care of the secant, if you like. And this is going to be something like 4 plus x squared dx. You see, the denominator is of the form of something like 1 plus tan squared, if you like. So this should be easier to take care of. So you will see this type of format when we want to check this case. Okay, so let's check it to see if I don't know whether I think it's going to be easier. So the solution is going to be, you see the format is a 4 plus x squared, so you have to use the tangent. So use x equal to the 2 tan of the data. Okay, and you remember your dx is going to be 2 secant square of the data d data, and your tangent or the end of the problem is x half. Okay, substitute. You can simplify then substitute, or just go ahead substitute there so that you'll be able to simplify it a little bit. Okay, so let's see what we are going to have. So this is going to be x cubed originally, a square root of 4 plus x squared dx. Substitute for everything, especially dx. So this would be x cubed, this is it, 2 tan cubed, so that gives you 8 tan cubed of the data, that's the top. The bottom one is going to be 4 x squared is going to be 4 tan squared of the data times dx times it by 2 secant square of the data d data. Make sure don't miss this one, otherwise things would be so complicated. If it's going to be complicated, you probably miss this dx. Now go ahead, simplify. So this is going to be 8 tan cube of the data on the top. Now the bottom one, look at this one. If you factor out the 4 inside, so that gives you 4 times 1 plus tan squared. 1 plus tan squared is secant squared. So this would be the square root of 4 times secant square of the data. Okay, and multiply by 2 secant square of the data d data. Okay, go on, take the square root. So the top is 8 tan cube of the data. The bottom is 2 secant of the data. And over here you have 2 secant square of the data d data. Okay, now simplify. 2 and 2 would cancel out. This secant would be out, but there is going to be a leftover of a secant here. So the final answer would be what? Would be 8 tan cube of the data times a secant cubed, secant of the data, okay, is going to be secant of the data, d of the data. Okay, now this integral is easier to handle. Remember, you have the odd power of a tan and a secant. So what you do is you are going to pull out the tan on the data, secant tan, which is the derivative of a secant, and change everything else into the secant, and then you'll be able to do it when you have an odd power of the secant and the tan. So it's going to be equal to the, take the 8 out. So take 1 secant tan here together with your d data. This is going to be your du if you like. So what's going to be the leftover? The leftover is tangent squared. This is the derivative of a secant. So change this one into a secant. So it's going to be 8 integral of, it's a secant square of the data minus 1 times it by secant of the data, tangent of the data, d of the data. Okay, so you pull out the 1 secant tan for your u prime. You have to change everything else to the secant. Then you'll be able to do it. Tangent square is secant square minus 1. Now distribute it and then you'll be done. So it's going to be secant square of the data. This is the way you write it down. Secant of the data, tangent of the data, d of data, minus 8 1 times integral of a secant of the data, tan of the data, d of the data. Now we are ready for it. You see, you take this one to be u, this is u prime or du. Okay, so this is going to be 8 integral of u squared. So that gives you u cubed secant, okay, secant cubed of the data divided by 3. And this would be minus 8, and this is simply derivative of a secant. Secant of the data plus the constancy. So the final answer for your integral is 8/3 of the secant cube of the data minus 8 secant of the data plus the constancy. Okay. Of course, you are not done. You have to substitute. You have to change it to the x. Okay. So remember what you have here is you have the tangent of the data. Tangent of the data is x half. So you get the right triangle. That is going to be the data. Tangent is going to be the opposite adjacent. So this is 4 plus x squared. Now find the cosine. Okay, find the secant. The secant is 1 over cosine. So the cosine is going to be 2 divided by this radical. So the secant is the other way around. So I just write down here 8/3. Okay, so your secant is going to be a square root of 4 plus x squared over 2 all cubed. And it's going to be minus 8 times 4 plus x squared over 2 plus the constancy. Of course, you simplify, 2 to the 2 cube would be 8. Then you can simplify it a little bit to get the final answer. Okay, so these two would be simplified. You get the 4. I simplify it. Okay. So remember, you have to change it to the x. So what I did, I find the secant. I find the cosine here. Cosine is going to be 2 divided by the radical. So the secant is reciprocal. So that's why I switch it to get this number. So eventually, this is going to be the final answer. You were working on x cubed integral over 4 plus x squared. So this is going to be equal to what? It's an 8/3. Okay, this is going to be the 8/3. Now we have the radical 4 plus x cubed to the third cubed over 8, because that was, that's a 2. Okay, so this is going to be cubed, the top and the bottom. And this one is going to be just 4. So it's going to be minus 4 square root of 4 plus x squared plus the constancy. The only thing you can do is simplify these two. You can simplify the top if you like. So the final answer is going to be the top. You can leave it as you like, or 4 plus x squared times radical 4 plus x squared over 3 minus 4 plus x squared plus c, the final answer. Okay, so they just give you in a format like this one, so that you'll be able to, because the original one is too much. The original one, always you end up with a secant cube. Always we get a secant cube, and so they want just to avoid that. So they just, they change it a little bit for you. But secant cube is going to be around for a couple of these problems. So it's unavoidable. So you have to have, you make a note and you just keep it to get these numbers. Okay, so this is going to be the type 2. The type 3, again, if you want to go with the original one, you will end up with the secant cube again. So unless they change it a little bit, okay, so I just show you what would happen to this case. So that's a number 4. If you want to get the original one, I show you, you get the secant cube again. See, this is the original one. When it's x squared minus 1, you have to go with the secant, because secant squared minus 1 would be tangent. Just make sure you know it. If it's a 1 minus x squared, you replace it by the sign. If it's x squared minus 1, that's a type 3. You are going to change it to the, okay, secant. So for the solution, you need x to be equal to the secant of the data, because that gives you secant squared minus 1, which is tangent squared. And your dx would be secant 10. Okay. Now substitute. You can simplify, then substitute, or just go for it. If you want to go for it as is, so it's going to be integral of x squared minus 1 dx, which is, that's it, integral x squared. That gives you secant squared of the data minus 1 outside dx, make sure don't miss it. Secant 10 d data. Secant squared minus 1 would be 10 squared. This is going to be 10 squared. You take the square root, you see, that's it, I write it down for you. It's going to be 10 squared. And then you have a secant 10. Again, that square root is positive because the tangent is positive, so that gives you integral of a 10 secant 10 d data. Now the 10 would be 10 squared. So you get the secant of the tangent, secant times 10 squared of the data, d data. You see, you end up with the even power of a tangent. Then you'll be in trouble because if you want to stay with the tangent, you need a secant squared that you don't have it. So you cannot take this one to be u. So what we do is, since it's even power, you have to change it to the secant squared minus 1, then take care of that one. That's why you end up with the secant cubed. Okay, so it's always the case for, if you given the original one. So that gives you secant square of the data minus 1 d data. Then you distribute it, you get the secant cube of the data minus the secant of the data d of data. See? So you are going to end up with the secant cube of the data d data minus integral of a secant of the data d data. So again, you have to take care of the secant cube. You better memorize the secant cube. We let you use it if it's going to be on this test, on this quiz, because it takes times to be able to do it. But we did it for the other problem, so it's going to be 1/2 of the, I think it was 1/2 of a secant 10. Okay, I have to look at it again. This is where I used it here. This is it. So we let you use it. It's going to be 1/2 secant 10 and 1/2 the ln. Okay. So it's going to be 1/2 of the secant 10 plus 1/2 of the, it would be the same thing here. 1/2 of the ln of the absolute value of a secant plus tangent. That's for the first two. Okay, but it's a minus. Integral of a secant is going to be what? It's going to be ln of the absolute value of a secant 10 plus tangent. Secant plus, this is that one. You can simplify this one. 1/2 minus 1 would be negative 1/2. So it's going to be 1/2 secant of the data, tangent of the data, minus 1/2 ln of the absolute value of a secant of the data plus 10 of the data plus c. I can just combine the like terms of 1/2 minus 1. You bring the secant, which is easy in this case because x was tan of the data. You see, your x is secant of the data, which is going to be what? So this means use the reciprocal that give you cosine. So that give you cosine of the data, which is going to be 1 over x. So if you get the right triangle, this is going to be your data. And the cosine is going to be what? It's going to be 1. This is x. So you end up with x squared minus, oh no. Yes. This is going to be adjacent. Okay, adjacent over the reciprocal, sorry, that's x. So that gives you x squared minus 1. You must get the one that you know you integrated, radical x squared minus 1. So you can substitute now because you have the tangent and everything. So this would be the final answer. X squared minus 1 dx is equal to the 1/2 of the secant, which is x, tangent. And the tangent is going to be just radical x squared minus 1, opposite adjacent. Okay, and this is going to be 1/2 of the ln, the absolute value of a secant, which is x plus radical x squared minus 1 plus the constancy. Sorry. So just pick these from from the given triangle that I have. 1/2 of the secant. Secant is x. Tangent is radical x squared minus 1 from the right triangle. And this is just a repetition of that one. Okay, so if it's going to be just, so the tangent, or that substitution of the tangent and the secant, originally you will end up with the, okay, you will end up with the integral of a secant cubed. So you better check that one. But again, when we want to give you this one on the test, so what we do is we just, give you divided by x cubed, like the other one that I did, so that you'll be able to simplify it. So you should expect these type of problems. Okay, I'll just give you one of them. You will see them in your next practice one. Because the original one, it takes time to do it, but you'll be surprised when you see the one that you are going to apply. So that's a number 4. I give you one more to see that when, the actual one that we see. You see? That is x squared minus 4. If you want to do this one by itself, again, you end up with a secant cube. So they divided by a power of the x to simplify it. That give you x cubed, for example, here tx. Anytime you see this type of expression, you'll be happy because probably this would be easier to handle. Okay, the format is x squared minus 4. So you need secant because you end up with a secant squared minus 1, which is going to be tangent. So your substitution is going to be x equal to the 2 secant of the data. Just make sure to get your dx. So your dx would be 2 derivative of a secant 10. And the d data. And for the record, secant of data is x/2. This is going to be for the end of the problem. Substitute, simplify it. So start with the given integral. So that would be what? This is going to be x squared minus 4 over x cubed dx. Substitute. A square root of x squared would be 4 secant squared of the data minus 4. The bottom one x cubed, so this is going to be 8 secant cubed. Then you have the dx, and the dx is 2 secant data, tan data, d data. Just make sure don't miss the x. Okay, now the inside, you factor out the 4 that gives secant squared minus 1, which is tangent squared. So it's going to be the square root of the 4 tan squared. Okay, you can simplify one of these secant and you simplify 4. So that gives you secant square of the data. The leftover over here is going to be tan of the data, d of the data. Okay, because one of the secant cancel out. Okay, go on the top. On the top, that give you 2 tan, tangent of the data, and this is going to be secant square of the data, and the top is going to be tan of the data. Okay, this is going to be the case, and the d data. So multiply the top, that give you 2 tan squared, 2 tan square of the data divided by secant square of the data, d data. You have to find this integral. Okay, you better change it to the sine and the cosine, which is easier to handle, and then you take care of it. Okay, that would be easier. Okay, you can also, change this one into the secant square minus 1, then easily can simplify. So you have two choices to simplify. If you want to do it quickly, let's say pull out the 2. So tangent square would be sine square of the data over the cosine square of the data. And this would be 1 minus 1 over cosine square of the data, d data. Okay. Because sine, cosine, and the secant is going to be 1 over cosine. So these two would cancel out. So you end up with what? You end up with 2 integral of a sine. Sine square of the data, d data. And you can easily solve it. You know that you have to change it to the double angle because it's an even power of the sine. So it's going to be 2 times double angle. It's going to be 1 minus cosine of the 2 data divided by 2. So the 2 and 2 cancel out. So you end up with the integral of 1 minus cosine of the 2 data d data, and you integrate it. The integral of 1 is going to be data. Integral of cosine is going to be sine, but it's going to be sine of the 2 data over 2 plus the constant c. If you like, you change the sine into the 2 sine cosine to simplify it. Data minus 2 sine of the data cosine of the data over 2 plus the constant c. These 2 and 2 would cancel out. So you end up with the data minus the sine of the data cosine of the data plus the constant c. Okay, now you have to bring your right triangle to substitute. You did have the sine of the data equal to the, you see this is what you have. You have the secant of the data. You have the secant of the data equal to the x half. Use the reciprocal that give you cosine of the data, which is going to be 2 over x. So you get the right triangle. This is data. Cosine is what? Adjacent. And this is going to be hypotenuse. So this would be x squared minus 4. So you substitute here. So data would be one of these. Is going to be secant inverse of x half minus sine. Sine from here is radical x squared minus 4 divided by x. And the cosine is 2 over x plus the constant c. The final answer, x times x would be x squared. So the final answer would be secant inverse of the x half minus radical, 2 radical x squared minus 4 over x squared to get the final answer. As you can see, when there is a coefficient divided by x squared, the operation is much easier. And this is the way we usually question you to get these numbers. That's it. So very easy and very important sections. Trig substitution. Just make sure you understand which the substitution are going to use. Okay, a minus x squared, the substitution is going to be the sign. X squared minus a squared, secant, and it's going to be plus tangent. So we're done. That's it. That's a 7.3. 7.4 is going to be integration by using the rational functions. We call it partial fraction. Okay, integration by partial fractions. It's not difficult. It takes time, a little bit heavy. So I will post another one for you over the weekend for that one. It's a very long one, so I cover everything. Then when we're done, that would be 7.4. So there is one section on so-called improper integrals. So we get the improper integral, then we are done with the integrations. Then the second part would be much more interesting. It's interesting too. Okay, nothing to worry about. So have a look quickly. If you have any question, let me know. Okay, I grade your test. I have a look at it over the weekend to see what's going on. Okay, so the next step is your quiz. Take care. Have a good one. So if you need anything, email me. Bye-bye.